Welcome, ladies and gentlemen, to this video lesson about the scientific revolution. This is part one of 2 video lessons that will explain the basic content you need to know for the scientific revolution. I'm Ms. Jennifer Blank, and I'll be your guide on this journey. Special note, prior to watching this video lesson, you should check out my video lesson on the causes and effects of the scientific revolution. That'll give you a good kind of intro and lead you into the specifics and details we're going to discuss right now. All right, so essential questions, some things we want to think about when we're studying the scientific revolution. So how is the scientific revolution a change in both science and in thought? Okay, so you want to think about that. What are the causes and consequences of the scientific revolution? Who is impacted by the scientific revolution? And how are those people or groups impacted or affected? Okay. All right, so here's a little multiple choice question. All the following were causes of the scientific revolution except A, improvements in scientific instruments. B, the contributions of medieval universities. C, the recovery of classical scholarship during the Renaissance. D, the challenges of navigation during long sea voyages. Or E, the active support of the papacy. Take a second. If you want to pause the video and consider that, that's fine. All right, answer in 3, 2, 1. Oh, E, the active support of the papacy, because if there's one thing we should learn by this point in European history, the church is not supportive of anything that in any way changes the status quo. The status quo being that the church has absolute power and omnipotence in all things. So there you go. All right, so let's talk about some causes. I discussed these causes in my previous video lesson, so I'm not going to dwell on them very long, just going to mention them again. So medieval intellectual life and medieval universities, Italian Renaissance and the humanism, the Protestant Reformation, renewed emphasis on mathematics, the Renaissance system of patronage, navigational problems of long sea voyages, I refer to that as the age of exploration, better scientific instruments, and the printing press. All right, so let's look at some detailed causes, okay? So we have the scientific method, which we should all know by this point what that is since you've been studying it for eons, almost since you started school, right? So a scientific method, of course, begins with some kind of question that you want to answer. You develop a hypothesis, then you've got to develop a methodology, a procedure for how to go about experimenting or testing your hypothesis. Then you have the actual experiment itself. You get data, you analyze that data, draw conclusions based on that data, and then after that, you have the development of further questions, or you need to go back and further refine your hypothesis, retest, lather, rinse, repeat, as it were. Now, some people we need to talk about, some individuals who had very important achievements. We're going to talk about these folks in detail during the course of part 1 and part 2 of these video lessons. So Bacon, Descartes, Newton, Copernicus, Kepler, Galileo, Boyle, Hooke, and Harvey. All right, those are key scientific revolutionaries that you should be involved in. And you will notice that some of these people will also kind of shift into the Enlightenment period as well. Descartes is a prime example of that, of somebody who's really important for the Enlightenment. So is Newton. Okay, so key inventions. We have the mechanical clock, the magnetic compass, gunpowder, lenses, as in glasses. All right, the telescope, the microscope, the printing press, horse collar and shoes, the stern post rudder, and the windmill. So these are important key innovations and inventions that you should be aware of. All right, an overview of the scientific revolution. All right, so we have this creation of a new world view. This is important. Humanity, specifically the intellectuals and the elite in Europe, are seeing the world in a very, very new way. They are questioning old knowledge and assumptions about that knowledge and about humanity and the world itself. Pardon me while I take a sip of coffee. I stay caffeinated for everyone's protection. See my mug. A yawn is a silent scream for coffee. Well, let me turn that. There we go. Yay. Okay. Back to brass tacks. We have a new focus on understanding the natural world. This is something that scientific revolutionaries find very important. So instead of the old world and superstitions and the unseeable, we're focusing on the seeable, the natural world, what we can experience through the 5 senses, right? We have a gradual replacement of religious and superstition assumptions based on superstition. Gradual, ladies and gentlemen, gradual. Let me explain why I emphasize this, because as you should have already seen, or you certainly will see throughout this course, whenever you have sudden radical change, it doesn't tend to be lasting change. Case in point will be the French Revolution when we get to it. But gradual systemic change is change that lasts and change that builds on itself. Okay, and this is one of the reasons why this new worldview actually solidified and became a thing. It was gradual rise of science and reason in astronomy, physics, chemistry, and biology. Again, the emphasis is on gradual here. I want you to make a particular note of the gradualness of these things. All right, so key people in astronomy. You got Ptolemy. All right, he came up with geocentrism, right? Then we have Copernicus, who replaced him with heliocentrism. That became our new model for the universe, all right? You should know what those are. Geocentrism is the idea that everything revolves around the Earth. Heliocentrism is the idea that everything revolves around the sun, all right? We have Brahe. I always mispronounce his name. He gave us a more accurate position of the planets, and Kepler, and he's the one who gave us the elliptical planetary movement. See, prior to Kepler, everybody just thought it went in circles. If you look at the Aristotelian model, it's circular, right? And elliptical is actually accurate. That's how we were able to track the position of the planets and understand their actual rotations. All right, so physics. We, of course, have Galileo. He's also important. Newton with the idea of universal gravitation. So these two guys are very, very important in the realm of physics. Like I said, Newton's also going to be important in the Enlightenment. All right, anatomy and chemistry with William Harvey. And this guy accurately demonstrated blood circulation. This is how we figured out that blood circulates to the body, and not just that it does, but how it does, right? Chemistry, Robert Boyle, this guy's important, made this respectable, it's disciple, my bad, that's a typo, discipline, my apologies, a respectable discipline which would replace alchemy, all right? And he articulated the arrangement of atoms determines matter, right? So he's the one who figured this out, very important stuff. All right, now let's spend some time discussing key people in the scientific revolution. All right, Bacon. Bacon, Sir Francis Bacon, right? Not bacon like like pork bacon that you eat for breakfast, but Sir Francis Bacon, equally important. I also like bacon, but not the bacon we're talking about. So inductive reasoning. This is working from particular to general conclusions versus deductive reasoning, which starts with a general conclusion and then devolves into particulars that support that conclusion. So inductive reasoning is much more compatible with the concept of the scientific method. You start with this theory that you don't say is true or untrue. You say, well, I have this theory that I think this is how things work. Let me see if that's correct. Then you go through and do all this experimenting, and your work is not a waste of time if you discover that's not how it works, that your hypothesis was wrong, because you just go back and create a new hypothesis. So you haven't lost anything. As a matter of fact, you've gained additional knowledge. Inductive reasoning supports that endeavor. Empiricism. Empiricism is the basis of all scientific thought. So this theory of inductive reasoning that calls for obtaining evidence from direct observation and experimentation. Again, all of this gives you the scientific method. Bacon is, for lack of a better term, the father of the scientific method. So this guy is pretty important, right? Okay, so let's look at Descartes. Now, Descartes looked at deductive reasoning, okay? He started with general assumptions and then worked downward. He also came up with geometry. So for those of you who are currently in geometry, you can blame Descartes. Rene Descartes, that's the guy. You can blame him, curse him, whatever you want. Personally, I had an easier time with geometry than with algebra. It's really Pythagoras that I want to slap upside the head, but you know, hey. So in geometry, any algebraic formula could be plotted as a curve in space. So what I just said kind of doesn't even make sense, like why I have a problem with algebra, because you're taking algebra and making it visual, right, in geometry, but for whatever reason, letters just mess with my poor little brain. I expect them to be inside primary documents and not an equation, right? But that's just me. Cartesian dualism. This is something you must know. Must know. All right. Division of reality into thinking substance and extended substance. You're like, what the heck does that mean? This is a question to ask your AP European history teacher. And for those of you who are taking my online class, this is something that you will explore via documents. So documents are coming, and that will help explain what these things are. But you should understand what Cartesian dualism is. The scientific method, all right, the scientific method is very important. Descartes added on to that and kind of advanced it further. So I want us to take a look at this little chart down here, dualism versus monism. Okay, so on the left with dualism, you have this idea of Cartesian duality, right? You have matter and you have the mind, okay? Now, the physical and mental substance is either fundamental or derivative. Now, what does that mean exactly? This is a question to ask me in class. Yes, we're going to talk about this in class. So you need to specifically ask me. I'm looking for you to watch these video lessons and then ask me. My online students, we're going to have a class discussion about this online. Okay, so in monism, physicalism is that the mind is less than matter. Matter is greater than the mind, right? And idealism, the mind is greater than matter. So then you have neutral monism, where there's a third substance that is actually greater than matter and mind, right? So this is all very confusing. This is something that I can't adequately explain in a video lesson. This is something that's going to have to be discussed. So I just want to enter this idea into your mind. Don't freak out. We're going to talk about it. But this is the beginnings of our discussion of Cartesian dualism. All right, Copernicus, bless his heart. So poor thing had some issues with the church, of course. His aim, however, was to glorify God, though. And so he differs from many scientific revolutionaries of his time who were seeking to kind of get away from faith and from God. His aim was to glorify God through this concept of the sun-centered universe. He challenged the idea of circular orbits. He was the first one to do that. He said the universe was of staggering size, so much that we can't even conceive of it. And he said Earth was really no different than any other planet, which totally flies in the face of what the church said, where we are like the chosen species, according to God. We are like the chosen beings in the universe that God created. And he produced On the Revolutions of the Heavenly Spheres in 1543. Okay, so Copernicus was an interesting guy, and even though the church pow-powed him, his goal actually was to involve God in the entire process and to glorify him. All right, Brahe, right? Most sophisticated observatory of his day. He was an arrogant nobleman, all right? He remained an Aristotelian. Despite the fact that he challenged the circular orbits, he still fundamentally believed in the Aristotelian construction of the universe. He discovered comet shooting right through crystalline spheres, so he's the guy that brought comets to our attention. So good times. All right, Kepler. Love me some Kepler. Look at Johannes Kepler. That's just a cool name. All right, so he was a student of Tycho's, okay? He said planetary motion conforms to mathematical formulas. Enter mathematics again. Science and math are not mutually exclusive. Matter of fact, they're mutually necessary. That one needs the other. With the emphasis on science needing more math. Planets do not move at uniform speeds in their orbits, all right? Depending on where they are in their orbit is going to have an influence on their speed. Galileo. Gotta love Galileo, right? He was an early practitioner of the experimental model. He created a mathematical formula for the acceleration of falling objects. He's the one who came up with the law of inertia, or discovered it rather. His discoveries using the telescope were very, very important. And he challenged the existing categories of form and of matter, okay? Isaac Newton. We love Newton. Newton was far from the perfect rationalist, but he was a great synthesizer. Now, you should pay attention to that word synthesis, because that is a point on the AP Euro exam, the DBQ, right? So we should pay attention to synthesis. He was not a perfect rationalist, but he was an excellent synthesizer, right? Bringing things together and making sense of them, okay? He blended inductive and deductive methods of reasoning for spectacular results. He argues for a universe that's governed by natural laws, okay? His work, Principia, Mathematical Principles of Natural Philosophy in 1687 was really, really important. It was groundbreaking stuff, all right? And he is the patron saint of Enlightenment thinkers. Enlightenment thinkers drew a lot of their, because they don't draw anything because they're dead. They drew a lot of their inspiration from Sir Isaac Newton. All right, that is the end of part 1. I will see you in part 2. Hope you learned what you needed to. See you next time.